Alright, so today we're going to do some analyzing of polynomial graphs. So we got some vocabulary terms here at the top. Relative maximum, relative minimum, and those are kind of shown on these two graphs here. So sometimes a polynomial, like the first picture here, this is obviously an odd degree because I'm going opposite directions. One end goes up to positive infinity. The other end goes to negative infinity, so we really don't have a maximum or minimum because this is going up forever, this is going down forever. So we have what we call these relative maximum and minimum. So it just says the greatest value of the points in the region of a graph, and it's in a certain area. So basically, you know, if I looked between negative, well here, like about right here, let's say like negative 10 or negative 15 to 15, what we would call the relative minimum. There's like a little dip right here. That's a relative minimum. It's going to occur at what they call a turning point, or almost looks like the vertex of a parabola. Same thing here. This would be what we call a relative maximum, just in that region. Now, if you have an odd degree, you do not have what we call an absolute maximum or minimum. So I've got a little picture over here to illustrate that. So the absolute maximum or minimum means there's no other point on the graph above a maximum or below a minimum. So this example right here, the ends here both go, as it says, approaches negative infinity here. So absolutely the top point on that graph, there's nothing above that. That's your absolute maximum. You also, as you can see, you have a relative maximum. You do have a relative minimum here. But we don't have an absolute minimum because both ends, left and right there, your end behavior is going to go to negative infinity. Okay, so absolute value, the greatest y value of the entire graph. Now, this does not exist if the end behavior goes up on both ends. So it does exist on this one, but if we have end behavior where both ends go up, absolute minimum, the least y value of the entire graph, and that does not exist if the end behavior on both ends points down. So absolute max and min can only, these guys can only happen if you have an even degree polynomial. And that's what that says right here. Oh, it does not exist for an odd degree polynomial. Okay, so here's what I'm going to go through and just kind of point out. We don't have any specific points on the graphs here, so I'm just going to have you guys look at the graphs and just point out relative and then absolute max and min. Alright, so odd degree, this guy right here would be what we would call a relative max, and we'd have to grab the point there. We don't have any labels on the graph, so I don't have any specific y value for you there, but that would be your relative maximum. This guy right here would be your relative minimum, but we don't have an absolute max or min because right here this end goes to negative infinity, this end goes to positive infinity, so your end behavior looks like that. End behavior here. Now, both ends go down to negative infinity, as you can see. So I do have, like this picture up above here, this would be absolutely the maximum point on the graph. So I'd grab the y value there. Also in this region, though, this guy a little bit lower, this would be called a relative maximum. And this dips right here, kind of like the bottom of a parabola. This would be a relative minimum. Now, this graph right here, both ends go up. You don't have a relative max or min in this picture. All we have right here, this would just be an absolute minimum because that is absolutely the bottom of that lovely graph. So we're just looking kind of at the pictures here to identify. We're going to get into specific values in these graphs underneath. Okay, now, we're going to answer all these lovely questions about this graph here. And I'm going to use my highlighter for this bottom part where we're going to do some increasing, decreasing. We've done that a little bit in an earlier unit, but we're going to review that today with this polynomial graph. Okay, domain. These are x values, and you want to go from left to right to read this. Now, this goes down forever, this goes up forever. Any polynomial function, any of these, the domain should go and cover the entire x-axis, so negative infinity to infinity. If you have an odd degree polynomial, which we totally do here, this end goes down to negative infinity, this end goes up to positive infinity. These are y values, your interval you would want to describe from the bottom to the top. If it's an odd degree, you're automatically going to have negative infinity to infinity. Okay, now zeros, these are kind of marked on the graph as you can see, so I'm just going to go ahead and list where the graph crosses or touches the x-axis. So this one has 3, -5, -2, and 3. You can just list the x values if you want to, or you could list the entire coordinate point. That's completely up to you. I'm just going to list the x values there. Y-intercept, just where the graph crosses the y-axis, and you got that right there. 0, -15. And we're looking for relative max and min. So we don't have an absolute maximum or minimum on this graph because one end goes up forever, one goes down. So that doesn't exist for an odd degree. This point right here is like the top curve, like we're turning from increasing to decreasing, so you can have an absolute max or min anytime that turn happens. So these are my two relevant points. This is going to be my relative maximum. Now, you just grab the lovely y-coordinate of the point. So I'm just going to, let's just call this 7.41. I'm just going to do nearest hundredth. I got these graphs off Desmos and it rounds it out to 5 decimal place. So let's just go 2. And you can, but you don't have to. I'm going to go ahead. I'm going to say the relative maximum. The maximum is actually the y-coordinate, but you can say where it occurs. So I'm going to say that occurs at x equals negative, let's go ahead and round that, 3.67. Now, the relative minimum, this is at the bottom, like a bottom vertex of a parabola kind of looks where it goes from decreasing to increasing. This is a nice number. -18 is actually the relative minimum, and I'm going to say at x equals 1, just so you know where on the graph that occurs. Okay, now, increasing, decreasing. These are x values that you're going to describe where the y value is increasing. So I'm going to go from left to right as we do this. I'm just going to grab a highlighter and trace this. So as you go from left to right, just decide what you're doing. So if I'm drawing on this, I am drawing up, so this piece of the graph is increasing. When I get to that relative maximum there, then I turn, and then this portion of the graph, the y values are going down as I'm tracing it, so that portion is decreasing. And then I'm going to turn again, and the rest of the graph would just continue up forever as that lovely arrow indicates, so that would be increasing. So we're going to grab x values as we do this. Remember, the far left of the graph is negative infinity, the far right is positive infinity. So as I'm traveling along here, this was increasing, so it starts at negative infinity, and it's going to switch over at these turning points where the graph turns direction. This just so happens to be a relative maximum. Now, make sure you're grabbing the x coordinate. I'm just going to go nearest hundredth here. So from negative infinity until I get right here, that graph is increasing. So that's that negative 3.67. Okay, now I stop here, and again, it's parentheses because at that actual point you're not increasing or decreasing, you're turning, so it's kind of like it's flat or staying right there. So wherever I stop increasing, that same number, that 3.67, should start up where the graph starts to decrease. So then I'm going down, 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 and I stop going and decreasing with the x value is 1. So then this is 1. Now, wherever I stopped, that should start up the next interval. So the next interval is increasing. So I'm going to put that little union symbol. So from 1, okay, now the rest of the graph is going up, but you are describing what's going as you're traveling to the right. So from 1, for the rest of the graph, you would be drawing up. So it would be 1 to infinity would be your interval where it's increasing. Okay, now on the back here I just have different graphs. So domain for any polynomial is left and right forever, should cover the whole x-axis. I know it looks like it goes up really fast, and it does, but it does go left and right forever. Now, your range here, if this is an even function, if you have an absolute maximum or minimum, which we do here, anytime you have an even function, your range is going to stop or start at a specific value, and that's a y value. Don't forget that. Now, go from the bottom to the top. You're not having arrows pointing down here, so I'm not touching any part of the graph till I get to this lovely point right here, and I'm just going to go nearest hundredth again. The lowest y value, the first y value I touch, which we'll have a bracket on because we're actually touching that point, I'm going to say that's about negative 4.87. And then the rest of the graph goes up forever, so we're going up to positive infinity. Infinity symbols always have parentheses. Let's see our zeros. We're just going to go across the x-axis. So it looks like negative 2, we have 0, and we have 1. Now, you don't have to write this or anything, but just to remind you from last week, if you don't actually go through the x-axis, that says negative 2 right there, that has to have an even multiplicity just to create that bounce where it doesn't go through the x-axis. So just as a reminder there. Y-intercept there is actually the origin, so 0, 0. Okay, now let's talk relative max, relative min, absolute max, absolute min. Okay, over the course of this graph, these ends go up forever, as you guys can see. This point right here would be what we would call a relative maximum. So I'm going to go ahead and grab that y-coordinate, about 6.24 at the x value. Again, I'm just rounding to the nearest hundredth here, 0.84-ish. Okay, now, if you're looking for a relative minimum here, we actually have two minimums. Okay, so I've got one right here. This one is farther down. So this one is absolutely the bottom of this graph. You do not have an absolute maximum because these go up. So absolutely the bottom of that graph is that negative, and that should be the range. If you have, that'll be the number in the range, negative 4.87, and that occurs at the x value of about 0.59 if I'm rounding to the nearest hundredth. And the relative minimum, and this is a little weird because it's right on the x-axis, but this bottom of this, where this graph turns right here, the relative minimum would be 0, the y-coordinate, at x equals negative 2. And we're just going to do increasing and decreasing here. So if I'm tracing this graph, right, from left to right, this is going down, so this is decreasing. Then I'm going to switch to increasing, and then we're decreasing again. I'm just going to kind of color these guys, and then I'm going to go back and write these intervals. The rest of the graph going up forever is increasing. Alright, so these, think about negative infinity, switching right here, we're switching right here, and we're switching right here. This is going to go to positive infinity. Okay, now the first piece is decreasing, so I'm just going to start there from negative infinity till I get right here, and we're grabbing the x values, negative 2. Now where that interval stops, the next one should start up, so also at negative 2 I start increasing because we're not increasing or decreasing at that point. Now do not grab the y-coordinates here, we're going left to right, so this continues to increase till I get right here, which is that x value. Again, I'm just rounding to the nearest hundredth, about negative 0.84. Where that stops, the next one starts. So we're at that same point, I'm going to put a little union symbol, that negative 0.84. Now, decreasing, decreasing, decreasing until I get here, but remember, you're traveling left to right, so I want to grab this x value down here, which is that 0.59. Okay, that stopped where I was decreasing, and then I start increasing again. So I'm going to use that same number, that 0.59. Okay, now, I know this is going up forever, but you're describing what it is going up, but you're describing as you're going to the right. So from 0.59 all the way to the right forever for the rest of this graph we are going up, so that should be to positive infinity. And I've got one more real quick here we're going to go through, and we're going to, on this one, talk about where the graph is positive and negative. So we did increasing, decreasing. I'm going to do positive, negative intervals on this graph to remind you what that means. So this switches over at the zeros, and I'm just going to jot those down here. We have -6, 0, and 5. So where the graph is positive or negative is where the graph, oh my goodness, forgive. This should say where the y is positive. So the graph is positive where the y values are positive. The graph is negative where the y values are negative. So if you want to think about kind of like the x-axis is like a line of demarcation, if you will. So if I'm above the x-axis, my y value is positive. If I'm below the x-axis, my y value is negative. So I'm going to just kind of grab my highlighter here. So this piece, all the y values are positive, and this little loop right here, all the y values are positive. And I'm going to grab a different color here. So wherever I'm below the x-axis, that's where my y values are negative. So there we go. And these switch over at the zeros. So again, this is x values. Here's your -6, this is 0, this is 5, this would go to infinity. Okay, so I have two intervals that are positive and two intervals that are negative based on what I just drew there. So first piece of the graph, from negative infinity till I get to -6, that's positive. Again, it's similar to increasing, decreasing on these intervals where I'm touching the x-axis. We are not increasing, or sorry, we're not positive or negative when the y-coordinate is 0. So that's why that has a parenthesis, not a bracket. Now, that stopped. Now I switch, this entire little loop is negative. So between the x values of -6 and 0, all those y values are negative. Then at 0, we're going to hop back above the x-axis, and all this time until I get over to 5. Oh, sorry, I forgot to put the 0 first. 0 to 5. Now, this is going to be, this will trick you, okay? So at 5, we start to go negative again. All right, now this messes people up. We are describing x values. You are going left to right. So as I'm going this way, all these y values are negative. So do not put negative infinity. You are describing left to right, so this should be positive infinity. From the x value of 5 all the way to the right. Like if I plugged into 100, it would have a negative y value. We just don't have an equation to look at here. But as you're going this way, the graph is negative. So you're describing x values for which the y values are underneath the x-axis are negative. Okay, now these last two, we are just actually going to use Desmos for. So let me pull this to the side, and it says kind of like we've been doing today, round to the nearest 100. So let me pull up my Desmos here real quick, and we're just going to do this on Desmos so you guys can practice with this. All right, now I'm just going to type in y equals. Now to get an exponent, there's a couple ways to do it. I hit shift and the number 6 to get an exponent. You can also get an exponent from this little keyboard here. So down there, you could do the squared and like change the exponent. Like I said, I just used the shift key and the number 6. It gives you a little caret, and then I just arrow out of the top. Plus 4x, shift 6, and I'm going to square that, arrow out, and then minus 5x. Okay, now remember, you can kind of squeeze the lovely graph with your fingers, and these are probably not nice numbers here, but that's the beauty of Desmos, because we can just click on these points and they'll give us these values here. Let me click on this guy first. There we go. Okay, so here's all the relevant information this question is going to ask for. Okay, so it wants the zeros. So in this particular example, we've got nice zeros here. So I've got -5, 0, and 1. Those do not have to come in any particular order. And this does have a relative max and a relative min. There's no absolute max or min because one end goes up forever, one end goes down forever. But if you're looking at the graph, Your relative maximum is just like at the top of where the graph turns right there from increasing to decreasing. So this is going to be about 24.19. And if you want to write, that occurs at the x value negative 3.19 if I round to the nearest, sorry, let me move that, nearest hundredth. Okay, now your relative min is going to be this guy right here. So the y value, that negative 1 point, let's say 38, and that occurs at x equals about 0.52. So the actual relative max or min is the y value, and then you can say, if you want to, at the x value it occurs at, just so we know where it's at on the graph, but you don't have to. Okay, let me try one more here with you. I'm just going to add a negative in front of this and kind of see if I can alter this equation a little bit so I don't have to totally retype it. And this is a cubic polynomial with 4 terms. We just did a cubic trinomial here. This is, as you can see, has different end behavior, and I'm just going to kind of click on these. Let me do this one first. Okay. Click on my zeros and click on the relative max and min. Okay, so your zeros, actually all nice numbers on this question as well. So we've got 2, 6, and 8. The relative max is going to be like looking at like a parabola turned upside down, like where the vertex would be is what it looks like. And I'm going to do 0.05 for our relative maximum, and that's at the x value of about 7. If we round that to the nearest hundredth, I'm going, actually we'll just have to go 7.10, or you can just put 7.1. All right, now your relative minimum is going to be right here, kind of the bottom of this, what looks sort of like the part of a parabola here. So I'm going to say that's negative 16.9 there, and that occurs at the x value of about 3.57 to the nearest hundredth.